So basically today we are to do. I think last time we agreed that we're going to do the hinge. So I think
Yes, those hinges.
okay. Then after the hinging, we'll now come back to foundation of this one or that one, right?
Okay.
Okay, so let's begin with a new just go back to normal view for this, normal view. Go out from this view.
From this design status,
Yes,
right?
yes, you're right.
That's here, right?
Yes,
None.
yes, none. Okay, so to now use how to hinge right now. I think
Yes.
okay, let's go back to that one that I gave to you. That let's use that
The
one.
other drawing.
Yes, yes, they are drawing.
Okay. Mm-hmm.
Okay. Have we done this on this? Checked on beam, Abi, right? You have checked the beams and all
Yes,
that.
yes, yes. We did this one together.
Okay, so what will happen now? Click on file and then save as. Save this drawing as a new file. Save as. Then you can just put two at the back, and then choose this option. Say copy all projects files. Okay.
Okay, now so I have both of them now.
Yes, exactly. The reason why I saved that
I've
because
always
once we
wa-
apply hinge on this now, it will
it
cancel
will
all.
scatter it.
Yes, all that you have done.
I've always wanted to know how to do that.
Okay, okay, that's nice. So right
All
now,
right.
to begin your hinging right now, just as it is during the like in school those days when they'll say moment at every end must be zero.
Yes.
Okay. So the same thing happens here right now. And the reason for that actually, although normally right now, as you're seeing this Protastructure right now, they now assume that
Mm-hmm.
everywhere is fixed. Can you hear
Okay.
me? Okay. So
Yeah, I can hear
so let me say by default, this software fixed every end condition to be a fixed end. So right
you.
now,
Mm-hmm.
I know what fixed end does. Fixed end um used to increase numbers of reinforcement at the top, because just like if you have a cantilever right now. Okay, let me see a diagram of a cantilever. Share first diagram of a cantilever. Can you hear
Sorry?
me? Yeah, let me see
Yeah, I can hear you.
yeah, let me see a diagram of a cantilever for one beam. Just click on beam and go to that beam section design.
Oh, like this one now.
Yes, like yeah, that one. Then let me see the diagram of it. Okay, now on this first area here where you have cantilever end, you can see that we have a top this in the moment there.
Yes.
So basically, that is how this software Protastructure takes every bin end to like, because when you have a fixed end, automatically at that fixed end area, it gives you a higher top moment
Reinforcement.
yeah, which will also give
A
you
moment,
yeah,
sorry.
which will also give you a top
Higher
yes,
reinforcement.
higher reinforcement at the top. Okay, now just say cancel and then go back. So, but basically, normally every bin end that is not a cantilever is meant to be hinge. That means that place should be zero. Moment there should be zero. So with that now, we have to
Okay.
apply these things. And also, the reason why that is also very, very important is because, you know, if you're if you have a higher top moment, let me say, where it's meant to carry zero reinforcement, and you're giving that it to have a reinforcement, invariably the cost of your design will be very, very high. You
Very
understand?
high.
Compared to someone that now applied hinge at the end, which is, let me say, if you're meant to have four numbers or bars at the top, that person that now applied hinge is now having two numbers at the top, of which both of the structures they are still stable. So that person is now having a lesser cost for the building, which will likely the person
Yeah.
will like win the contract. Okay, so right now, at every end of beam, what they mean by end of beam simply means that, like at this column 9, you can see that at this column 9, zoom out that place, let me see, zoom out, let me see, zoom out, let me see. Hello, are you there? Sorry, zoom in, let me see, zoom in, let me see, zoom in.
Okay.
Okay,
So,
okay, yeah.
okay.
So zoom in, let me see. Zoom in that column 9, let me see.
Okay. Something was playing on my headphone.
Okay, okay, that's nice. Okay, now at this
This
column,
is 9.
yeah, at this column 9 now, you can see that this beam 12
Yeah.
and this beam 16 has an end at this column 9. That means that beam 12 and the beam
Yes.
and beam 16 does not continue after that column 9. So at that place
After
right now,
this.
yes,
Yeah.
so at that place right now, that is an end condition. So right now, the end condition of beam 12 and beam 16 is meant to be a hinge end, because that is the end of those beams. So with that right now, you now click. So let us hinge the end of beam 12 right now. Click on the beam 12, right click and say apply end condition. Can you hear me?
Okay. No, so I was trying to write down what you just said. I'm
Okay,
coming.
okay,
Is
okay.
meant to be hinged
Yes, every beam end is meant to be
because they are
hinged.
not continuous, well.
Exactly, yeah. They are not continuous, so they're meant to be hinged.
Okay.
Okay. So click on beam 12 right now. Click on beam
Uh-huh.
12, right click on it and say click on update beam end condition. Don't click that, just hover there, and you see now you have seen these four options, right? that
Yes.
that first option is no hinge. Then second option that you're seeing there, hinge both end, is if you're having a simply supported beam, then that means you are going to use
Okay.
that second option, because both of the ends are
And
not continuous.
same,
Yes,
yeah.
exactly. Then now on this place called J and I, on this when you once you open your software Protastructure, the top side of the
Mm-hmm.
software simply means J, and that bottom part simply means I. To just get it very, very clearly, just once you open your software, just just with your own eye, divide your screen into two. Upper side means J,
Okay.
bottom side means I, and then also divide it
Okay.
again into two again vertically. Left hand side means I, and the right hand side means J. You understand?
Okay.
So right now, with
Yeah.
this beam right now, if you divide this beam into two, you can see that this beam at this end condition is at the bottom, which means I. So choose I.
I.
So yeah, so choose I. Now, since we have already, okay, now use that first option, apply to stated beam. That's the option that you'll be using for all that you'll be doing, that first option. Because once you click on that second one, it will apply on all the beams.
Okay.
Okay, now since you've already done this in before, design before, that's why you're seeing this option. Now zoom out that place, zoom out that zoom in that column 9. You see that that symbol has now been applied. It applies as a 0. Can you see that symbol? Circle symbol.
Okay.
Okay.
Yeah, yeah.
Yes, that symbol right now means that that beam is having a free end moment.
Okay.
Okay, so do the same thing at beam 16 at
Six.
that end. Same thing at I because that's the left hand side.
Yes, it's left.
Okay. Okay, now you can now see the same thing. Now just palm up a bit, palm up a bit, palm up a bit. No, palm up. Sorry, palm down. Like, let me see the bottom of that. Now stop. This beam, that's beam 41. Let's hinge that one.
Yes.
That will be both ends because both of the ends they are discontinuous, so they will be both end option. Can you see
Okay,
that?
here too is discontinuous and here too is
Exactly.
discontinuous.
Since both ends are discontinuous, so we are going to use um both ends option for the
Hinge both
hinging.
ends.
Yes, exactly. Apply to selected beam. Okay. So do the
Mm-hmm.
same thing right now for beam 27. Hinge at I because only at left
The
end is
left.
yes, and left end is discontinuous. So that's how you're gonna
Mm-hmm.
apply for. Or now, just for you to be fast, for you to be fast right now, zoom out small, zoom out a
Mm-hmm.
bit to see the whole drawing. Now, that you have known what they call I end and J end. Now hold your control key
Mm.
and then begin to select all the beams that are going to hinge at I end.
This can what of these
No, no,
cantilever
no,
beams? They
no,
are not
no,
part of
no. You
it
don't
now.
hinge cantilever end. But what you hinge now on,
Okay.
no, sorry, zoom out. This cantilever area right now, what you hinge is at the J end, but at the I end you not hinge because there's a cantilever beam at
Yes.
the yes. So right now,
At the end.
select all the ones that are hinging J. Sorry, I I end
Okay.
I end.
And these ones are going to hinge I, right?
No. Those ones are cantilevers, so you don't hinge that one. You don't hinge.
Um,
You don't hinge cantilever ends, cantilever beams. Leave them as their cantilevers. Don't hinge them because
okay.
they are meant to be fixed. Okay, I end, not J.
But that means basically it's we have this here
Okay.
too. Are we going to okay? These ones now are we
Yes.
going to hinge the cantilever that's
No, no,
connected
no,
to it?
no.
Okay.
But you hinge that horizontal beam. That one will be hinged. Yes, that one will be hinged. Yes.
That's this and this now. These two. That's what I'm asking of.
Yes, they'll be hinged. But first of all, select
These
all the
two.
I. No. Select all the I first. That's not an I. That vertical one
Okay,
is
that's
J.
it will be a J.
So vertical
Yes.
ones also at the bottom. We also hinge. These ones near the staircase will be hinged at I and both J. So first of all, hinge the I end first. No. Not that one. Not that one. The next beam. The next beam below it.
This.
No, vertical
Sorry.
one. Vertical one at the staircase below it.
That's
Yes,
this one.
that one. Because if you hinge that one that you just choose now, it will go and hinge on the column 10, which is not possible. That place is not an end. So select that vertical long beam. Yes, that one. And choose that one
Mm-hmm.
at the below. Yes, that one. Choose that one.
This one.
Yes, that one. And also this other one.
This one.
Yes. So choose all the I end at that line. At that line. That one too will be hinged. Yes. And the left
This one
end.
too.
No, that one will be both end. That's both end. So leave it. Just the I end I'm
Yeah.
saying.
Okay.
And next one, which is the grid line Y2, still at the bottom area. Grid line Y2 bottom area. That's an I end.
Yeah,
Then on
actually
grid
left
line
here.
S4, grid line S4 horizontal, grid line S4 horizontal. That's an I end. Yes, that.
This one.
No, not that one. Left I end of it of the beam. Yes, that one.
This.
Yes, that one. And on grid line A, that cantilever end, which is the left end, should be hinged. No, this other beam, not that side. On the other side, yes, that one should be hinged.
This one.
Not that one. The I end of it, which is column 19, that end should be hinged. Yes, that beam. So right now, right click and apply hinge at I end. Now check if they have all applied. Check the symbol if they have applied. Okay, that one is there. That one is there. Okay. So now do the same thing that you just did right now and select all the J end. All the J. So now this one now the J now will now be, let me see if you can select J. Select all the J ends. Holding your control key. That one and the vertical one too, yeah, correct. Then let me see again. All the J end beams should be hinged. Yes, that's okay. That's fine. On the staircase area, that those two should be hinged. Not that one, yeah.
These two.
Yeah, exactly. That two should be hinged.
Okay, because they terminate here.
Exactly. Then also on grid line 4, the end of grid line 4, right hand side should be hinged. The end of grid line 4. Sorry, S4, grid line S4. Right hand side should be, yes, that one.
Okay, yeah.
Also on grid line S2, the end should be hinged. J. S2. S2. S2.
Okay,
Yes,
this one.
yeah, that one too.
This one.
No, that one is
Uh,
at I. Don't choose that vertical one. Select that vertical one.
okay, yeah,
So,
it's on the left hand side
uh,
because it's down here.
exactly. So now
Okay.
apply hinge first. Then after I will check for the apply that one first. J. Okay. Now select the both ends hinge, which is the simply supported beam. They have all hinged. Okay. Select the both
Mhm.
ends. I think they're just two, which is the that one and no, not that one. The vertical one up there.
This.
Yes, that one. That's on both ends now.
Yes.
Okay. And
And
also
I
at
think
this,
we have one.
yes, this button side.
We have one down here, right?
Yes. Left hand side. No, left hand side. You can see it there. At grid line 7, grid line Y7 button, grid line Y7 button, there is a both end hinge there.
This one.
Yes,
This,
that
yes.
okay, that yes, that one.
Then
I think that's all. We have
okay,
already hinged that one. Yes,
we've
that's
done that
all
one
for the
before.
right click and say both ends. Okay, now zoom in that staircase area. Yes, there. Staircase area. One of the continuous beam. Just zoom in one of the continuous beam. Let me show you something. Okay, now, okay, yes, that's okay. Now, zoom in, let me see the beam, that beam name. Now, we don't hinge. Now, you can see that that's a continuous beam. We don't hinge continuous beam at the mid
Yes.
span because they are like continuing. Do you understand? Like that one now, we don't apply hinge
Mm-hmm.
there because there is being continued at the left and also at the right. Do you understand me?
No, please repeat it.
Okay. At that beam now, which is that zoom in, let me see the name of the beam. That's beam 37. 37.
Yeah, 37.
We cannot hinge that end because we can't hinge that beam because at the left end there's a beam of 36, and at the right end there is beam of 38. So basically all
So it's
continuous beam,
continuing.
yes, all continuous beam are to be hinged at the ends only. At the ends where there is no beam continuing at it. Do you understand me right now?
Yes.
Okay, because once you hinge any midspan of a continuous beam, what you're saying is that there should not be that place should not have a top reinforcement, which is basically it is meant to have a top reinforcement. Because if you check that beam the beam diagram, check it, let me see right now, I'll show you the diagram, what you see there. Check the beam diagram of that continuous beam. Those 2 points are having a top reinforcement. So just say okay, because we have already done yeah, now check the diagram. Now you can see that that two ends has a top reinforcement, has a hugging moment.
Yeah.
So if you say that place should be
Yeah.
zero, yeah. So if you say that place, so if you gonna apply hinge there right now, what it means that it will not gonna provide
Yes.
it will not provide the top reinforcement which is meant to be there. And also it is not okay. Do you understand?
Yeah.
So we only hinge at the ends of the cantilever. Sorry, at the end of the continuous beam, which does not have any beam in continuation. Okay, so let's go back right now. So the same thing applies to all continuous beam. Cancel. Just exit. Let me see. Exit. Okay. So the same thing applies to all continuous beam, both vertical and horizontal. That's why,
Yeah. All these ones.
yes, that's why we didn't hinge intermediate cantilever beam. Sorry,
We
intermediate
are meant
horizontal
to
beam.
hinge this
Yes,
one.
yes, that one too should be hinged. That one should be hinged
We are
at
meant to
J.
hinge
Yes,
this
yes,
one.
hinge it at J. At J end. Okay, okay. So this is how you hinge.
Same thing
Basically,
with this one.
yes, same thing with that one. So basically, most people using Protastructure, they don't do all this because they see it as very, very stressful. But that is why why the software gave you that option, so that you can be able to apply those hinge if you know it.
Mm,
The reason why the software didn't apply it is because, one, softwares always like to play safe because they just assume that the person using the software don't have enough experience. So just to be safe, they just went and applied fixed end at all the beams. You understand?
yes.
Okay. So this is how you're meant to do your model first before you can now begin your design. Once you finish modeling, before you begin to now insert story, the first thing to do is to do this, because right now that we have done on story one, we want to do that also on story two also. But had it been we have not yet first of all created story two, and we just do this right now. Once we insert story, it will still carry this same hinge to story two. So right now, go and apply the same hinging principle on story two while I just watch you. Are you there? Hello, are you there?
Yeah, I'm here.
Okay, so
Mm.
let me see you hinging story two right now.
I'm here. I'm here.
Okay, so hinge story two. Apply the hinge end at story two too.
Okay.
I think there's no cantilever here, so basically you have
All right.
continuous. Sorry, you have,
Here it's pretty straightforward.
yes. So you have. So let me see now. Use your control. Use your control to select all the both ends, all the both ends, because that one now you just do now is both ends, right? Can you hear me?
Is both end? Yes. Yes.
So use your control this to select all the both ends.
Yeah, I can hear you.
Okay,
I'm selecting.
okay. Is that all? That's not all. Oh. You need to let the one on
It
a
has
grid line 9.
done this. I'm coming.
Okay, okay.
Grid line 9. Which grid line 9? This one?
Grid line Y9,
Okay, yeah,
Y9.
this one.
Yes, that one. Then also those
Okay.
smaller ones also, and the two corner beams, the two corner beams too.
These small ones.
No, no, the button below. There is below. Yeah, the two small ones at the ends. No, below. Like come down. No, like yeah, those two simply supported beams.
These ones.
Grid line Y7 and grid line 1 vertical. Yes, those ones. They are simply supported beams, so they should be hinged. Then also the corner beams. There is a corner beam that I have not selected there too. Hinge that one first. Hinge that one first. Okay. Are you there?
The both ends are hinged for this.
Okay. Apply both ends hinge. Can you hear me?
You said which one? This corner one?
Yes, that corner one.
Yeah, I've done that.
No, let me see. That one, yeah,
This,
that one. You don't know that. Okay, okay,
but,
yes.
but
I've
you
seen
know
it.
this is a
Yes, I've
cantilever
no, no, no.
beam.
No, that's not cantilever now. That beam is resting on a cantilever beam, but it's not a cantilever. Let me see. Yes, that's a cantilever. Don't
The
hinge
way it
that.
is. Okay. This
So,
one will hinge this one that's resting on this beam.
which of them?
You know there's
Yes.
a small beam here.
No, that's a cantilever. Don't hinge it, but hinge the one resting, which is the
Okay.
vertical one resting. You hinge it.
This.
Yes, that one should be hinged. Also, the that end of it, like the that side of the building too, should be hinged also because it's like they're like twin. Sorry, let me pick this call. Hello? Yeah, where are you? Yeah, good morning. Okay, where are you? Where are you coming from? Okay, yeah, come now, come, yeah, come fast there. Okay, okay, yeah. Sorry, I received a call. Sorry. Hello? Yeah, sorry, I received a call.
Where?
Okay,
Okay. Okay.
okay, so let me see. Okay, now begin to hinge your I. Yes, that one too should be hinged. Have you hinged that one? Okay, yes, you've done that. So check if you have
I'm
hinged
selecting them now.
all your I ends. Oh, all your I ends. The one installed on grid line A is not an I end. Sorry, I end that grid
This
line.
one.
Yes, that's a both ends. So select it. Yeah, that's both
Okay.
ends, right? Yes, that's both ends. So hinge down first both ends. Also, the other side of the building too should be hinged. Both yeah, this side too. That's both ends because they are simply supported beams. Okay. All the I ends. Okay. Okay, now do the J ends. Okay. Okay, now let me begin to see if you have done all. This one at the staircase area, you didn't hinge it. J end. Okay. Let me see. Now begin to zoom the ends. Let me see if you have applied hinge on all the ends. Okay, that's fine. This one here, this one here. This, yeah, no, this vertical one at grid line Y2. Abi? Yes, that one is not hinged. Yeah, it's not hinged. Hinge it
Yeah.
at J.
But even this one too needs to be hinged at J.
Yes, at J too. That one. Okay. Let me see again. Just pan. Let me see. Pan. Let me see. That one too. That one should be at I.
Yes.
No. So hinge I. No. Escape first. Just escape. That one is I. Why the vertical one is J?
Oh, why the other one is J? Yeah.
Exactly. Okay. Let me see. Let me just pan. Begin to check the end. Let me begin to see the ends. Okay. That's fine. That's fine. Go down. Okay. That's fine. That's okay. Let me see the other side. Okay. Let me see up. Okay. Okay, that's fine. Now then, what you should know is that if you're hinging, make sure you don't apply any error in hinging. Let me say the place that is meant to carry I, you now want to hinge it at J.
Yeah.
That will give you an issue because that will give you issues during your structural design. You understand? So when you have done your hinging, always check again. Always check each of the joint again of the beams, each of the joint of the beams. If they all agreed to your hinging principle.
Okay.
Okay. So it is when you have done this right now, when you have done all this, you can now perform your bidding analysis and your design. All right.
Okay. So
Okay.
now basically that means the reinforcement at these edges will change.
Yes, they will change. If they are giving you three before, they'll be giving you two. You understand? If they're giving you four
Okay.
before, they
Yeah.
you can have some three or two. Okay, so save so that I can go to a foundation design for you. So just say save.
Okay. So maybe later I can do the analysis here and see.
Exactly. So let us go back to the first one which we have done before, analysis before. Although, can you hear me?
Okay. Yeah.
See, if since this is a smaller building, since it's a smaller building, you might not be able to
Yes.
see the changes because
The
basically
changes.
exactly. But
It's,
let me say, if you're doing a massive building, you understand, a very massive building, that's when you'll be seeing like the help of this hinging.
yeah.
Okay, so let's see the other one that I just saved us.
How are they?
so that we can do the foundation design for the.
Good morning.
Hello?
Yeah, yeah, I'm with you. Just say open. Say open.
Who is talking?
That's this one.
Yes, that one. Open it so I can do.
Okay.
Okay.
Who they greet me now?
So since you have already finished checking all the beams and you have done the design of this building,
With
it's time to now do the
Yes.
foundation design. So
Okay.
right now to
We are not checking the columns.
okay, let us check the columns. Now go to your tree on column on story one. Click on that column, right click and say section designs. No, that first, yeah, that one, that first one. Click on that one. Now all you just do is to check if your columns are giving you a good diameter. As you can see there, or it's giving us diameter 4y16. You can see that,
Yes.
right? And all the designs
So
are
what's the meaning of this?
okay. That U ratio. U ratio simply means, in let me say in reinforced concrete, there is
Yeah.
what they call compression zone and tension zone.
Yeah.
Yeah. So and also for a design to be good, both in beams, concrete, any kind of member, your U ratio should be at least either less than one or at least up to one, maximum one.
you sure it's from my room?
Can you hear me?
Okay.
If your U ratio is more than one, let me say you're having 1.8, 1.9, it means that that concrete member has a higher um rebars reinforcement. That means that that compression zone, which is the rebar area, is trying to enter
Yeah.
into the compression, is trying to enter into the concrete zone.
Okay.
But if they are less than one, that means they're like okay. That means concrete zone is on its own. Steel bar area
Still zone is on
yes,
its
it's on its
own.
own. But if you're having more than one point something value, that means that
Okay, so
steel zone is
you
trying
are
to enter.
basically having more steel
Exactly,
than
more steel.
concrete.
So what you should do is either you can increase your size of your member, either your beam or your column,
Mhm.
so that it can now separate itself. You
Okay.
understand the hair? So right now that they are less than one, they are okay. That means there is space between the concrete zone and the steel zone, rebar zone. Okay, so right now you just check all
Okay.
your rebars if they are all okay to what you want. From the thing we are seeing here, we are having at least maximum to be 4y16, and the spacing of the
Yes.
links they are still okay. Y10 at 175 spacing. So this is how to
Sounds
check
fine.
your column. And if there is anyone failing, you just double click on the one failing. Double click on the one failing. Let me just say double click on column one, column C1. Double click on it. Double click. Now on this place you can now choose to go and increase your size. Let me say increase the size of increase B2 to be 300. Now then just say on but say that place update. Then try to on the design. You can see that top place say the interactive design. So run that right now. It will not give you your new design. Then click on OK. So now stop. You can see still stop. You can see that place showing blue, and that place showing
Mm-hmm.
that place now is called the steel zone, the rebar zone, and the place showing gray
Okay.
is called the concrete
It's
zone.
concrete.
Yes. So if maybe you're designing for a very massive
Okay.
structure, that's when you'll be seeing this blue side. You like try to cover up that gray side. So once you begin to see all
Mm-hmm.
those things, and once your U ratio is already more than one, you begin to increase your size of your column or your beam if it's beam. You understand?
Okay.
But for this right now, I think it's okay. Which your U ratio is around 0.63. So you just say okay. Just say okay. But right now, since the column is not failing, so carry it back to 225. 225. Else it will go and change that size of column on the main model. Okay, then click on OK right now. Okay, so you can just close this dialog box since I've already shown you how to do that. So this is how you check your columns. Okay, so right now we now go for foundation design. Do you know how to share your screen where you can see your 3D view and also your plan view? Yes, that place. But that place right now, you need to click there. You need to get the view port 2 first. So go to view first. No, hold on. Go to view, right click and say 3D view. No, yeah, view there, 3D view. Then do the same thing back that you did now. Share your screen again into 2. Then it will now arrange. Okay. Share your screen vertical. It will now it will arrange itself. But take this plan to be on the left hand side and 3D on the right hand side. Okay, just arrange it. Okay. Now click on the plan view interface. Plan view interface right now. Go to story 00 on this side. Yeah. Story 00. Now zoom in. Zoom in. Now let's perform the foundation design right now. I think from our course outline, the first foundation we have there is part foundation.
Yes.
Okay, and also since this building is also a small building, and let's assume that the bearing capacity of this building is 120, so which is okay for a part foundation. Okay. Now for a part foundation, the minimum bearing capacity you can take for a part foundation is 75 kN per meter square.
Okay.
Anything less than that, you have to go and choose either a strip foundation or a raft foundation. Okay, so right now let's assume that this building is to be sited in, let me say, Abuja or Rivers State, which has an average bearing capacity of 120. But basically, before you must do your design for a structure, you must have to have your soil test. But I think I've already told you when you don't have your soil test what to do before this time.
Yes.
Okay, so let's assume that the bearing capacity of this soil right now is 120. So which takes us to a part foundation as the first choice that we are going to choose for the foundation design. So click on one of the column. Click on one of the columns. Hello, are you with me? Hello, are you with me? Okay.
Yes.
Now right click and
I'm with you, I can hear you.
Okay, so right click and say insert part base. Yeah, correct. Now on this dialog box right now, you are meant to just input just 3 values. The first value you input is the footing depth. Now on this footing depth right now, at least minimum footing depth that you are meant to assume or you're meant to start with is 250 millimeter. So let's assume, since this is a small building, let's assume 250 millimeter. Then if there's any failure, we're not going to increase that footing depth. So once you input this footing depth, leave that place called such height. That place always comes with the soil test, but even if you didn't see the soil test, just leave it as default. Next thing, go to allowable soil stress, which simply means the bearing capacity. Okay, so
bearing capacity.
let's take 100. Let's take 100 since we already have 120 here. Let's take 100. 100. Then let's do right now is now choose your steel bar sizes. Choose on X and on Y. Click on that arrow and choose. On the arrow, choose 12. Since this one-story building, you choose
Small
12.
building.
Yes. But had it been for the two-story building, you have choose 16.
Okay.
Okay, so right now click on calculate. Then first thing to do is to click on square footing. Choose that option, square footing. Okay. Now on this place, basically what you're meant to check out is for your punching shear failure and for your punching failure and for your shear failure. So you can see that on the place called punching check, that 3 OK must be there. If you have anything failure there, what you have to do is to then increase your depth of footing.
Size.
No, the depth of footing. Once you have any failure here, you have to then increase your
Okay.
depth of footing.
Okay, yeah, for punching.
Yeah, for
Actually, yes.
punching. The same thing for shear failure. On this place called XX direction, that's for shear failure. If you have anything called failure there, if that place is not okay, you're not showing okay, you have to go and increase your depth of footing also.
Okay.
The same thing on the Y direction also. On the Y direction, if you're having any failure, if this place is not showing okay, you can increase your depth of footing. Then on this place also showing steel bar area, which is having 225 spacing or other spacing, that is your reinforcement area spacing. On this other side now, minimum spacing that you're going to allow is at least 125 or 100. But I always say you should allow 125. That is the minimum spacing of reinforcement that you're going to allow. If on this place, if you're having failure on this side, two things that you're meant to do. That means if your spacing is below 100 or 125, two things you have to do. Either you can increase your depth of footing, or you increase your size of reinforcement to like 16 to a higher bar. You understand?
Higher bar.
Like if this place is showing less reinforcement, you just click on that arrow showing Y12 and choose a higher bar. Yeah, you now choose a higher number of reinforcement. Higher size of, do you get me? You choose a higher diameter of reinforcement on that area.
Yes, I did.
Okay, so right now, since you have checked all this right now, and we are having our pointing check is okay, our shear failure area is okay, and the spacing of the reinforcement is okay, which is more than 100 or 125. We can now say okay right now. So click on OK, and then click on OK. Okay. So on no account will you go and decrease your bearing capacity.
Okay.
Because that's the bearing capacity that will carry the structure. So on no account will you go and decrease it. So all you have to do is to go and increase your depth of footing if there's any failure. Now the maximum depth of footing that you can allow, which is also economical, is 500. But me, I don't even go that high. I used to end my maximum at 400. So if at 400 I am still having failure, that means it is time to go and change my choice of foundation from part to strip foundation or a half foundation.
Okay.
Because when you start having a footing thickness, footing depth of more than 500, even the clients will have to question you, because you see that it will be very expensive to construct that. And also that also guides you also that building is having a very high axial load to the soil. So just to be safe, you go and choose your next type of foundation, which is strip, and consider strip. Okay, so with this example right now, Okay, let
Sorry,
me hear you. Any question?
I want to ask you something, right?
Okay.
But strip foundation is actually different from like pad with foundation beams, right?
No, strip foundation simply means that you are going to have a ground beam. You have a ground beam.
Yes.
Then that ground beam right now will now sit on a footing, on a footing, concrete footing.
Okay.
Yes, that is just like a semi-raft beam, because raft beam, you understand, it's like a semi-raft beam, because raft beam also have beams, ground beams.
Yes. No,
Uh,
what I was saying there is this.
okay,
For like strip now, right?
okay,
Or conventionally, what I understand by strip, as in foundation, is along the beam is sitting down as like when you excavate your trenches and everything. When you want to do your beam, right?
yes,
Can you hear me?
yeah, 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 yes, yes, yeah, yeah, I can hear you.
When you are doing your footing and everything will be basically the same size. Like if you try to do a strip foundation with Prota now, you see that it gives you a width. That's the width of the
Footing,
it will basically be as if, yes, it will be a width of footing along the entire stretch. It's
yes,
basically like the way a retaining wall will look
yes, yes, like a
under,
toe,
where you
like
have the heel
like a
and
toe, like a toe
yes,
or heel. Yeah, that's
the
true.
toe and heel and
Yes,
the wall. So, but some there's this other thing they do, that you do your footings then maybe because to chain them like a chain beam, but not a chain beam. This one is actually a foundation beam, a ground beam
exactly.
inside the foundation. There is that one is just the beam. You are not having, you have like your pad, then you are tying all the pads together with a beam. Normally, I think
Yes,
there is a depth of like 600.
yes.
Is that still strip, or it's actually different from
No,
strip?
no, that is called wide strip foundation, wide strip.
Okay.
because
All right. No
because
problem.
normally strip foundation is
Yeah.
that you are going to have only ground beam
Yes.
that footing. You understand?
Yes.
Yes, but once you have that footing under the beam, it's now called a wide strip foundation. Wide strip.
Okay.
Okay, okay, yeah.
Okay. All right.
Okay, so the same thing right
No.
now. Click on the columns and begin to insert your part foundation. Now, once you click, no more setting again. You just click on calculate because you've already done the first setting.
Oh. Okay. Yeah.
You
Actually, it
only
has
change when
adjusted.
you have a failure. You can change your depth of footing. That's all. Then click on square. You only change. Sorry, click again. Let me show you something. Now stop. Just stop there. Don't be too fast. Click on square and check. Make sure you check, because most times the depth of footing that pass a column at the corner might not pass the one at the middle because of the weight. You understand?
Oh, okay.
So always take time to like check. Most people go ahead to go and select all the columns and then insert pad immediately. That's not okay, because you will not know the column that is failing on the pad area. So always check it one after the other. So for me, click on OK. Okay. Click OK first. So for me, basically, I like to locate the column carrying the okay again. I like to locate the column carrying the maximum load, and then first of all use it to like design my first part footing.
Yeah. Okay.
You
How do
understand?
you locate that?
Okay. Now go back to your story one. Let me show you how to locate that. Story one. No, just double click there. Okay, now just zoom in. Let me see. Zoom in. No, like zoom in. Let me see all the buildings. Like zoom in. Let me see all the buildings. But in a bit, you can maximize close this 3D view so I can see it fully. Then zoom in. Okay, now stop. Now, actually, this part I'm to show you right now, you get the kind of experience if you carried out a manual design, because manual design will always open your eyes a lot, but just in a little trick, just to show you too. For me right now, the maximum column that will carry the highest axial load is this column. Zoom in on grid line 4. Those columns on grid line 4, the both edges on grid line 4.
Which of the four? Y4
Sorry,
or
X4,
X4?
X4, X4.
These ones.
That one at the edges. The column at the edge, yeah, that one. Zoom in that place. Yes. That one will carry the maximum axial load. That one and that column 18, column 17, and column 14 and column 19 is one that will carry basically the maximum axial load. The reason is because if you check the slab and the panel around them, you can see that they have larger panels around them.
Yes. Okay.
You can see that.
Okay.
Now, this one here, this one around the staircase, this column, and zoom in that place, staircase area. This column 16 and 15 would have carried the maximum, but because of the staircase void, it won't carry.
There's no slab here.
Yes,
So
and even there is slab there, that would have carried the maximum load. You understand?
Okay.
Then also this cantilever area, the cantilever area, which is the corner column at the top, that one would have carried the maximum also, but because the cantilever length is not that long.
Not that long.
Yes, it's not that long. That's why it will not carry the maximum. So this is how you locate the one that is carrying the maximum load. You understand? You just check the columns carrying the panels that the higher panels that are very large. So basically that column will carry the maximum. But if you're having a column at the edge and the cantilever length is around 2 meters, that column will carry the maximum. You understand? So this is how you locate. So I think if you go to foundation right now, check on column 18 and column 17. Go to and check if that 250 we're going to pass it. And check column 18 and check if that footing depth will pass that. I think it will pass it because the building is not that big, and also you can see that you can see that the size of the footing here is 1.5.
Yeah, 1.5. It has increased a bit.
Okay, so just say okay first. Okay, click on okay first, and then wait. Let me show you something again. Are you there? Hello, are you with me? Hello, are you there? Hello, hello, I can't hear you. Are you with me?
Hello?
Okay, yeah. So just click on
Yeah, I'm with
okay
you. Sorry.
first.
Hello?
Okay, yeah,
Someone
I'm
help
with
me
you.
do it.
Click on just the first okay, and hold on, let me show you something. Okay, now look at that place called axial load.
Yeah.
Okay, you can see the axial load right now. You can see that the size of this footing size is 1.5 by 1.5. Hello, are you with me? Hello, hello, are you with me?
Yes, I'm with you. I can hear you.
Okay. So
Yeah.
you can see that the axial load there is 207.35 kilonewton.
Yeah.
Now, when your footing depth is becoming very, very large, let me say this one gave us 1.8 now. I'm just assuming. there is a way you can go ahead and reduce your footing dimension, which is your footing size, which is on this place
Okay.
called use manual define load. Manual define load.
Mm-hmm.
Click on that place called manual define load. Check it. Now, basically, footing sizing in manual design, we size our footing using just the axial load and not the moment. And the
Okay.
formula is axial load all over the bearing capacity value. Then when you get an answer, you now square it. So right now, open your calculator. I don't know if you're going to have that square root value. Let me show you. Calculator. Now take it one side so that we can see. Take like palm it one side. Now our axial load there is 207.35. So do it. 207.35 divided by the bearing capacity, which is 100, equals to, copy that answer and do square root of the answer. Square root of the answer. Copy that answer and do square root of it. You can see that it's given up 1.44, approximately 1.5.
Yes.
So that was how we got that 1.5. So basically, what they use in sizing of your this thing of your footing set, that is the bearing capacity, is the axial load and the bearing capacity only. Now, most times when you're designing for your footing, this software tends to use this moment to size your footing.
Okay.
So when you're having a very large value of your size of footing, what you just do is to come here and make the moment 0, 0, and leave it just to use the axial load to like design, to like size the footing. Then during the design, it will go and pick just the moment and the axial load and now perform the steel design, like the reinforcement design. I don't know if you get me.
So
So
that's if you put the moment to be 0,
yes,
it during design to now just take only the axial load and bearing capacity.
if you make the moment to be 0, for the sizing, it will
Yes.
take just the axial load and the bearing capacity, just as we did here.
And bearing
But
capacity.
during
Yes.
the steel bar, like to narrate the steel number of steel, it will still go and choose this moment, even if you use it to be 0. You understand?
Oh, okay. Yeah.
So now make this one not to be 0, 0. Let's see if it will reduce the size to be 1.4, 1.00 again. Then click on calculate. You can see it now, right? Okay, you can see that 1.4. So you can see that actually, even from our calculation, it gives us what gave us was to be 1.4. Now on this footing length step, make it to be 10. Make it to be 10.
Sorry.
Footing length,
Yes.
yeah, make it to be 10. Just 10, not 100. 10.
What was that for?
Just I know I'll show you. Now click on OK and come back here again. And go back again. Calculate again. Calculate again. Okay, now click on square. Square. Now okay, it's giving 100 again. Now most times, now take it to be 10 again. Make it to be 10. Go back to your calculator. Calculator. Now, if you want to get, you can see that this thing that with no. Just click on that history. That on that calculator, that history, that arrow. I think it's going up arrow. The up arrow, no, like arrow that at that scientific area, you can see an arrow there. Circular arrow. No, circular arrow. Yeah, that one. Click on that place. You can see that our value for the footing gave us 1.43. Let's say 1.44.
Mm-hmm.
That is actually 1,440. So if you want to get this exact dimension, as you put it to be 10 now, begin to add value on that arrow on the LS and LY. Just click on that up arrow. Exactly. So you can now make it to be 1.44. You can see that.
Okay.
That is if you want to get your exact value of what you have done with your mana calculation. You understand?
Yeah, I understand.
But if you make that step now, that footing step to be 100, what happened? It will be doing plus 100,
Maybe
100, 100,
increasing
100,
by
100.
100.
Exactly. So if you want the footing depth and your footing width to dimension to be by 50-50, that means you can put there 50, and what you'll be having to be
50.
you'll be having 150, 250, and all that. So that have to like play with it if you want to make your design very, very special. But for now,
Okay.
just make it to be 100. I think that's the default 100, so that it will just be a round figure. Then go back to click on square and then on square again. No, click on square and on square again. Okay. So click on OK. Okay. So you can now see how to reduce your if you're having a very large value of size, you can take off the moment and get the exact value of what is required for the to like carry that load on that column. Then also how to make your footing depth to what you want, either by 50 or by 100 or by 30 or by 10. Okay, click on OK and then insert footing for all this thing. Okay, I think you can do the rest for your using the same example. You can insert now. Okay, now click on this column 17. Let me see if that will give you combined base. I think that's almost a combined footing because that thing is like very close. Now, once you stop, hold on. You will see an error if you click on calculate because you did manual define load and your actual load is still giving you a 0. So once you do that kind of changes where you have to remove your moment, click back on the first option, try all combination. Now click on calculate, else you have an error issue.
I should click on.
Calculate now. Okay, now hold on. Click on back on that use a manual define load first. Let me show you something. Now click on calculate. You see an error issue. Calculate. That's because axial load is not yet factored. Now click on OK. And so once you make changes on your moment, all those things, you have to go and check back the first one first, so that it can now
Okay.
generate that axial load for that footing, for that column. So click on calculate now. Okay, now square and then say okay. I think this size is okay, so there's no need to like take off moment. The size is okay. Say okay, okay, and okay. Okay, now you can see that zoom in. You can see that is almost trying to combine. So you can also make a rectangular footing if maybe you're trying to, if maybe your footing, you have two footing that is very, very close to each other. You can also make a rectangular footing too, which you can click on that footing 18 and make it rectangular, make it 1.2 by 1.6.
This one.
Footing 18. No, footing 18. You click on the column. Click on footing itself. On the footing itself, not the column. Okay, yeah. Right click and say properties. Properties right now. Now change it to rectangular. Wait, once you show that little box. Okay, yeah, calculate now. And change to remove that square option and make it 1.6 by 1.2. Increase. Okay, no. Make it 1.6 by 1. Okay, that's fine. Or 1.5 by 1.2. Let's see. Okay, that's okay. Now click on OK. Always know that you check for punching, you know that. Always check for all those
Yes.
things. Okay, now click
Yes.
on OK. Okay, now. Okay, now you can see that we now have space, right? Okay.
Yes.
So this is how to, if you want to design for a combine, let me say if there is still chance for it to make a rectangular footing, then you can make the two rectangular. But if there is no way and you're meant to combine, you cannot combine footing. Okay, let me show you on the other side how to combine footing. The other side of the building. Let's combine that columns on that side. Okay, I think there's no column. Okay, yes, that one. So right now, to perform the combined footing, you have to select that two columns, these two columns. Right click and first of all say combine. You're not seeing that. Do it again. Select the two columns. Right click and say combine and combine that one first. Apply that option combine. You will see a warning. Just say okay. The one is coming out because that distance between that column is at least more than 1 meter. Once you have a column distance between each column more than 1 meter, you begin to see that error, but that's a warning. But that's the okay, that's fine. Now right click and say insert pad footing. It will combine those columns now together. Then check that first one, check the first one, try all combination. Make sure you do that, else it will show you error. Now click on calculate. I think that depth of 250 might not be able to pass this one because of combine. Click on that place, calculate. Let's see. Now you can see that. Now click on square first. Let's see square. Okay, I think it's still okay. Now you can see that the side of the footing is very, very large, which is
Very large, yeah.
Now go and apply that. Now you can also see that spacing here is giving you 125. Which for
Yes.
me,
One is
I don't allow. I used to allow at least 150. Because 125 will be so tight during construction, it will be as if the environment is so close to each other. You understand?
yes.
Okay, so right now, click on OK first. Let's make that size to be lesser. Remove the moment because you have a very large moment here. Moment will move to be 0, 0. Because if we check our manual calculation right now, this will give us at least 1.7 thereabout. If you check that calculation, that's 376.13, either 1.7 or 1.8 maximum, divided by 100, square root of that answer. Okay, 1.9. Okay, 1.9. Okay, now click calculate and see. Let's see if that gives us 1.9. Although it might give us 1.8 thereabout. Okay, 1.8. Okay, now you can see that there is failure there. Failure on the punching.
Yeah.
Okay, now if you don't want to use 1.9 as the thing gave us on the calculation, you go and increase. I want to use 1.8. Go and increase the depth of the footing to, let me say, 300. That is the only way we can now override that calculation of 1.9 that we did. Okay, that's okay right now. You can see that it's okay. So either two ways. Either you go and make it 1.9 and use 250, or you can increase the depth of footing and make it and use 1.8, which is closer. So, but if you look at the two, in both ways, you are still increasing the concrete, because if you increase the size to 1.9 and use 250, concrete will still increase. Or you can make it 1.8 and increase the depth 300, you are still increasing concrete. So in both ways, you will still use that exact area of concrete which is meant to be used for that footing. I don't know if you get.
Yes, I
You
understand.
understand?
What you are losing in depth, you are getting in size, width,
Exactly,
and
exactly.
either way, so it's roughly the same thing.
Exactly. But now you can see that our spacing of this now is now 175, which is okay. You can see that, right?
Yes, the spacing of the links, yeah,
Okay, but if you go
of
and use,
the reinforcement.
okay, now if you go and use 250 depth, that means you can increase your spacing, your side of to be Y16, so which might increase the cost, because with this right now, I think this one of 1.8 and 300 and having 175 spacing will be a bit lower in cost than going to use diameter 16 and
Y16.
1.9 and 250 depth. So I think this is okay. So now click on OK if you're going to choose for a combined footing. So this is how you choose your combined footing. Then say OK. You can see that. Then also, if you think that, no, zoom in that combined footing right now, combined footing. If you think that the edge of the column and the footing is a bit close, then that's your own choice to go and now increase to the size of footing to 2 point something, or you understand what I mean? But this alone
Yes.
right now is okay. But if you think maybe someone will go and question you on site, why is this thing, why is the column very, very close to the edge of the footing? Just to avoid those questions, either you make it to be rectangular footing individually, or combine footing and then increase to at least 2.0, just to avoid that kind of question on site. You understand?
Mm,
Okay. So let's see the 3D view of what we have done. 3D view. Okay, so you can now see zoom in those footing. Let me see. So you can see that, right? Okay, so this is how to
yes.
design for a single footing for a part foundation and for a combined footing, and also how to reduce the depth, the that footing width. If maybe the footing width is getting large, how to reduce it, and also how to what we did again today, how to check your footing size.
Yes,
Yes,
and the hinges,
exactly, and the
the hinging
hinges.
of the beams.
Exactly. So I think that's what we have done today. So I expect you to do the same, like complete the foundation design for this one, and also do the
Yeah.
same thing for the other one. Then I think you have done the complete design for this. Maybe next time when we come, we can export this to Protastructure. Then if you have any other plan, we can pick it up. Let me say, pick another plan. Okay. So what you do basically right now
Yes.
is to finish up this one that you have done now, and finish up the one that you're using to like practice. Then when we come,
Yes.
then pick up a plan if you have a building plan, at least the ones that are more complex. Let me say for a two-story building, if you have any building plan for that, you pick up a building plan
Yes.
for that, and then do the model to at least do the model, put all your hinging slab, if you have cantilever, and then we can use that to perform, let me say two-story or three-story building to perform either for a strip foundation or for a half foundation. You understand me? Then if you also
Yes.
have a building plan that has a curved beam or a curved cantilever slab, then you can use that also, model the building to that stage. Then I will show you how to form a curved slab or a curved cantilever slab, or a curved beam also. I, do you understand me?
Okay.
Okay, and
Yes.
then if you don't have a building plan that have a curved cantilever beam or a curved cantilever slab, I can send that to you. Then you do a model to that very stage. Then I can now show you how to model for a curved beam and for a curved cantilever. Then we can also use that and then insert like a two-story building for that, and then use it to design for a wide strip foundation and for a half foundation. I don't know if you get.
Okay.
Okay, so our next
I get.
lecture will be basically how to export this first to to export our details that we have done, and also generate our design reports. Then if maybe you have done a model for a two-story building, we can design for the wide strip foundation, or yeah, for a wide strip first. Or if you have done a model for a curved beam or for a curved slab, then I can show you how to um make a curved beam or a curved slab on with this software. Okay, I don't know if you get.
Okay.
Okay, that's nice.
Yeah.
Okay,
Can we
so
have a class tomorrow?
tomorrow is Sunday. Yeah, that's fine. Sunday
Sunday.
is fine. What? Yeah, it's fine. Maybe towards evening because my tomorrow, yeah,
Yes.
towards evening would be nice. Towards evening.
All right. No problem.
Okay, so
This
tomorrow.
week we are coming in, so you'll see me a lot this week.
Okay, that's fine. That's fine. That's fine.
All right.
Okay, so before we have our lecture tomorrow, that means if you didn't provide a model that has, let me say, two-story building, that means you are going to basically show you how to transfer your this thing, all your
To
design,
pro
to your
to
AutoCAD,
AutoCAD.
and also to generate
All right.
the reports. But if you are able to like model a two-story building, I will show you that and also show you white strip foundation design. You understand?
Okay. All right.
Okay,
All
that's
right.
nice. Okay, now, so we have got any question for today?
No, I think I'm fine for now.
Okay, okay, that's fine. Okay, so thank
All
you for
right.
today's lecture.
Thank you very much.
Okay, yeah,
Yeah, thank you very much. Have a
okay,
nice
yeah,
day.
yeah, you too. Bye.
Bye.
Okay, yeah. Okay, so this is how we take how this is how we perform Ekidel mentorship class and training. This guy is Mr. Gideon, which you can see that we sent him an email. You can see that email that was sent for Mr. Gideon for his training, and anytime he wants to, you can see his week one practical plan. We sent him a plan. You can see the plan also, which we are using. So you can also see the mail. You can also see the joining button for the online video. So this is a link which we use to join every day. We are having anytime we are having online class, and after our online class, we send in he will have to use the this plan that we sent in for his practical to perform his practical. And if maybe he has a plan which he have modeled, we can also use that also to perform the next lecture. So you can see how good Ekidel mentorship program is. We are not the one doing the design. You are the one doing the design, and then we will be guiding you on what to do, and you can see how perfect it is. So I will say that if you have the money, you can spend time to you can spend it on on how to develop yourself and the career for the Ekidel mentorship program. Okay, so thank you, and for you watching this right now, I will say that you can inbox up on WhatsApp, and we can negotiate on how you can begin your mentorship program. Okay, thank you, and God bless you. We love you.